Welcome to the next lecture in the data transformation or processing module. Here we are going through data transformation or data processing using Pandas. In this lecture, we'll focus on using custom aggregation functions. While built-in functions like sum and mean are powerful, custom functions allow you to perform advanced and unique calculations tailored to your specific needs. Before getting into details about developing custom aggregation functions in Pandas, first let us understand why we need to use custom aggregation functions. When it comes to custom aggregation functions, they are useful when one, built-in functions don't meet your requirements. 2, you need to implement specific business rules for analysis. 3, advanced metrics such as ranges, percentages, or weighted averages are required. Keep in mind, these are only some of the scenarios where custom aggregation functions are involved. Depending upon your requirements, you can think about developing custom aggregation functions in many cases. Let's create a custom function to calculate the range, which is nothing but a difference between max and min of sale amount for each sale rep ID. You should be able to develop the logic like this. First, let me run this so that Toyota sales data frame is created. Once that is done, let's define a function. The function name is nothing but calculate range. The argument will be series. Series means similar to some Python list or array. Here, using the series, we'll compute the max and min, and then we'll find the difference. That is nothing but the range. Now, when it comes to the logic is nothing but this one. Series dot max minus series dot min. When it comes to the usage, this is how you should be able to use. Let me create a data frame by name custom underscore aggregations, then equal to, then Toyota sales data dot group by, then sale rep ID. Within each sale rep ID, we are going to pass sale amount as argument. Hence, we have to specify sale amount. Now we have to specify the appropriate arguments to agg function. So in this case, I should be able to say agg. For agg, the first argument is nothing but total underscore sales. Here we'll be using predefined function sum. Hence, I am saying sum here. Then the second argument is nothing but sales range. Here I am passing calculate range as a value for this keyword argument, which means we are trying to invoke this on top of series object. The series object is nothing but sale amount. Keep in mind, each column in a data frame is nothing but series. Series is nothing but a list of elements or array of elements. So here we are invoking calculate range using all the values in sale amount, and using the sale amount we will be able to get max and min, and then we should be able to get the range. Now let me run this. It have run successfully. Let me copy this and then paste here and then run this. You can see the details here. So when it comes to each sale rep ID, the total sales is nothing but this one. When it comes to the range is nothing but this one. In case if you wanted to get min and max as well along with sales range, you should be able to specify additional keyword arguments as well. Now let me say sales underscore min equal to min, which means the minimum of sale amount by each sale rep. Then sales underscore max equal to max, which means it will give us the maximum sale amount for each sale rep ID. Then range is nothing but a difference between the two. Now let me run this and then let me run this. You can see the details here. Keep in mind, this is nothing but a difference between these two. That being said, the calculate range function which we have defined here, this is nothing but a custom aggregate function. It computes the difference between the maximum and minimum values in a group. You can see the logic in the return statement here. This return statement belongs to this function. By combining this function with agg method, we calculate not only total sales and custom sales range, but also min as well as max. Here we are able to get details about the total sales by sale rep, then maximum sale amount, minimum sale amount, and also sales range. As demonstrated, you can combine custom functions with built-in ones in a single agg call. However, let's go through another example where we'll be getting total sale amount, total number of sales, and also range of sale amount for each car model. For that, we should be able to come up with logic like this. Let me say car model aggregations equal to Toyota sales data dot group by, then car underscore model. Here we'll be computing aggregations on multiple columns, hence we'll not be specifying columns in square brackets the way we have specified earlier. Directly we should be able to specify the ag method call here. Then here we'll be coming up with 3 keyword arguments. The first one is nothing but total underscore sales. Here we need to specify the column and also the function, hence we'll be using tuple. The first element in tuple is nothing but sale amount. Then the second element is nothing but sum. Here sum should be specified as a string. Then we'll actually come up with count sales. This will be based on sale ID. We'll be invoking count function. Then the third one is nothing but sales underscore range. Again it will be based on sale amount. The function is nothing but calculate average or calculate range, not average. This is how you should be able to come up with the logic to compute total sales, then number of sales and also sales range based on car model. Now let me run this. You see it have ran successfully. Let's copy paste and then run this. You can see the outcome here. For Camry, the total sale amount is nothing but this one. Number of sales is nothing but this one. Sales range is nothing but this one. Here we have combined a custom function which is nothing but this one with built-in functions such as sum and count on different fields. By using this approach, we are able to generate multiple metrics for each car model. Keep in mind the metrics are computed based on multiple columns, not just a single column. The columns which are used per car model to compute metrics are nothing but sale amount as well as sale ID. So far, whatever examples we have seen are considered as simple custom aggregation functions. On top of these simple custom aggregation functions, we can also write more complex custom functions. We'll go to the details about writing more complex custom functions in the next lecture. Before moving on to the next lecture, let's recap what we have covered in this lecture. 1. We have defined custom aggregation functions for specific calculations. 2. We have used ag method to combine custom as well as built-in functions. Now it is time for us to get into the details about more complex custom functions, which I'll be covering as part of the next lecture. That being said, great job so far. You have steadily making some progress with respect to functions, especially custom aggregation functions. In this lecture, you learned how to create and use custom aggregation functions. In next lecture, we will see how to come up with more advanced and complex custom aggregation functions. See you there.